Right, let's go through this question. A carpenter is working on two long and thin rectangular pieces of wood which are positioned in such a way they can be molded by these two distinct planes, so pi 1, pi 2, right? With normal vector 1, negative 2, 3 and 2, negative 1, 0 respectively. So again, we got this plane 2 containing this point 361, and the line L, right, is where the two pieces of wood are actually joined together. So if I draw the side view, right, so this will be the side view, so this will be the so-called line. So for the line, we can solve using the appropriate method. Okay, so for the very first part A, find the acute angle between the two planes, pi 1, pi 2. Okay, so if we are trying to find the angle between the two planes, we will need to use cosine theta. So just use cosine theta n1 dot n2 over the magnitude of n1 magnitude of n2. So you just do the calculation. So this will give you a value of, I think, about 61.4 degree. Okay, the part B, we are asked to determine the vector parallel to the line. So of course, it's actually equivalent to saying finding the direction vector of the line L. So you just simply use n1 cross product with n2. So that will give you the direction vector of your line. So I do the cross product. So this will give you 363. So that's the two parts. Okay, so let's take a look at part C, a more challenging question, part of the question. The carpenter actually drew a tiny hole at this point A, alpha negative 3, 1 on this plane 1, where this alpha is of negative value. So point N is the foot of perpendicular from A to this plane 2. So plane 2, later I will need to do the scalar form of the plane 2. The carpenter then placed a thin metal rod of length 3 over root 5 that fits exactly between A and N. So find the value of alpha, meaning one value, and the coordinate of the foot of perpendicular N. Okay, so for this question, first thing I do the sketch. So this is plane 2. Then of course point A is here. Point A, apparently they say the position, so-called coordinate is alpha, negative 3 and positive 1. Okay, then with this I can actually form like a line equation, because the line equation I can just put r equal to alpha negative 3 1 and the normal vector, because this is the line, so apparently there's a normal vector, and this will be the so-called direction vector of the line 2 negative 1 0. Okay, then with this I form the scalar dot product of the plane 2. So the dot product will be r dot 2 negative 1 0, because this is your normal vector, equal to, so it's equal to a dot n. So our n is here. Then you dot product with any position vector that's lying on plane 2, which is 361, given to be as such. So you do the calculation that you will get 0. Okay, so based on this, I can do this thing. You suck inside here. So this will give you alpha plus 2 lambda minus 3 minus lambda and 1. Then you dot product with 2 minus 1, 0 is equivalent to 0, because I actually calculated here to be 0. Okay, then you solve for this equation. So this will give you 2 alpha plus 4 lambda plus 3 plus lambda plus 0 equal to 0. So this will give you 2 alpha plus 5 lambda. So the 3 I move to the right side. So this will give you negative 3. So that's the first equation. Okay, of course I will need another equation. To get another equation, I will need the idea of this 3 over root 5. 3 over root 5, right? So I do this. So from here to here is 3 over root 5. So if you can see, you can actually see a triangle here. So for example, I call this point P. So point P, right? So I just draw like a line here. So you can see that actually this part is what we call the length of projection. So I simply just use PA. So let's just say I just draw PA. You dot product with the n hat. Because now this thing right here is actually what we call the n hat. No longer the b hat, just n hat. But it's the same idea. So PA dot product with n hat. So this will give you PA you dot product with n hat. That will be the length of projection, which will give you 3 over root 5. Okay, so let's try this. So point P is 361. Okay, so PA is equal to OA minus OP. So OA is in terms of alpha negative 3, 1, alpha negative 3, 1 minus OP. So OP is just lying on the plane, which is about 361, right? Yep, 361. So this will give you PA to be alpha minus 3 minus 3 minus 6 is minus 9, 0. So that's the PA. Okay, now I want to do the dot product. So PA dot product with N2 hat. So this will give you alpha minus 3 minus 9, 0. And then you dot product, right? So N2 hat. So for this our normal vector, 2, negative 1, 0. So 2, negative 1, 0 is the n. Then you must do it with the unit vector. 2, negative 1, 0. Then of course I had it, so I just put a 1 over root 4, 5 in front. So of course this will give you 1 over root 5. Then I just do the dot product in terms of alpha. So it's 2 alpha minus 6 plus 9. Then dot, I mean of course 0. Okay, so this will give you 2 alpha plus 3 over root 5. Okay, so apparently we know that this whole thing right here is given the length. So they actually give us, the length is 3 over root 5. So, okay, so I just equate. Of course, this part equate to 3 over root 5. So the root 5 don't need to carry already. But you realize one thing is that the 2 alpha plus 3 is equal to 3. Then you solve for the alpha, you realize you get 0. Okay, the reason is very simple. Because you must do this. The 2 alpha plus 3, you must modulus it to give you 3. So means you need to solve for this modulus function. So it's 2 alpha plus 3 is equal to 3. So of course you do the calculation, alpha is 0, which is rejected because they say alpha is negative. So another one is 2 alpha plus 3. So when you unwrap the modulus, you will get negative 3 on the right hand side. So with this, 2 alpha equal to minus 6. Alpha is equal to negative 3. So this will be the negative 3 because they say alpha is negative. So this is rejected. Okay, so with this I already get my negative 3 alpha to be negative 3. Also this part is negative 3. Okay, then they want us to find what is the foot of perpendicular of n. Okay, this one's simpler. So with this I go back to this part because we actually found simultaneous, just an equation like that. So alpha is negative 3 means that 2 multiplied by negative 3 plus 5 lambda is equal to negative 3. So negative 6 plus 5 lambda minus 3. So 5 lambda is 3. 6 minus 3. Lambda is 3 over 5. Okay, so I get this value of lambda. That's where I need to sub inside because we know that point n right here also lies on this line right here. So you just sub in. That will be the answer really. So okay, maybe right here. On is equal to alpha. So alpha is negative 3 minus 3, 1. Then of course plus 2 lambda, I just write in terms of lambda first, minus lambda 0 plus 0. So the lambda we actually found to be 3 over 5. So this 3 over 5, this is 3 over 5. So this will give you minus 3 plus 6 over 5. So this minus 3 minus 3 over 5. Then this is 1. So this will be the so-called the foot of perpendicular. So let me just do the calculation. Hopefully I calculate correctly. 6 over 5. So this will give you minus 1, 4, 5. Then the second one, negative 3 minus 3 over 5 is about minus 3 3, 5, then this is 1. That will be the foot of perpendicular in terms of the column vector form. Okay, but normally they will ask for coordinate if I'm correct. Okay, coordinate of n, correct. So coordinate of n, just do a bit of rearrangement. -1, 4, 5, comma, -3, 3, 5, comma, +1. Done. So that will be the coordinate of the foot of perpendicular. So I will say not easy for part C, especially to determine the alpha. Okay, let us look at the part D as well. A third piece of wood is molded by this plane pi 3 to be fixed perpendicular to this pi 1, plane 1. And it's actually parallel, meaning that this plane 3 is parallel to the line L. Now the line L, of course, we actually get the direction vector from part B. So given that plane 3 also contain point P right here, find the Cartesian equation of this plane 3. Okay, so let us try this again. So plane 3 fixed perpendicular to plane 1. Okay, so this one you must do a bit of drawing. So let's just say this is plane 1. So plane 1, there's a normal vector, and this normal vector is given to be 1, -2, 3. 1, -2, +3. So definitely, right, they say, oh, I have this plane 3, I fix it perpendicularly to this plane 1. So this is plane 3. So okay, this one there's a normal vector as well. I think they never give. Okay, never mind. So they never give. So plane 3 fixed perpendicular to plane 1, and this plane 3 is parallel to L. So the L, I already got my direction vector to be 3, 6, 3 parallel. So meaning that if I draw the line, let's just say this is the line L. So this line L, so definitely there's one direction vector for this line. So it's about 3, 6, 3. This one 3, 6, 3. Okay, so we are asked any more information. Okay, so again, plane 3 contain point P, 3, 6, 1. So I just write now. So let's just say I just write 3, 6, 1. So this is point P. Okay, so we need to find what is the Cartesian equation. Okay, this one I will say simpler, definitely. Okay, so first thing first, I will need to look at this thing. So you can see that this thing, which is the 1, -2, 3, is actually one of the direction vector of your plane 3. So if I may, I also draw the 3D view of plane 3. So this is the 1, -2, +3. Okay, then actually there's one more. They actually say, oh, the plane pi 3 is parallel to 3, 6, 3. So again, so this is 3, 6, 3. So we got 2 direction vector. Then of course again we got a point P. We got 1 position vector. So always remember, for plane 1 position vector, 2 direction vector, right? This will give you the so-called equation already. So point P is 3, 6, 1. Okay, so based on this, let's do the Cartesian equation. But before that, you must do the vector first, vector form. So R for plane 3 such that R is equal to 3, 6, 1 plus lambda 3, 6, 3 plus alpha 1, -2, 3, where lambda alpha, right, is an element. I shouldn't put alpha, I should put mu. So this is mu, this is mu. It's an element of all real values. Then with this, I do the R dot n1. Okay, so it's R dot something something is equal to A dot something something. So okay, I just write this. R dot n equal to A dot n. So our n, okay, I must do the n first using the cross product. So 3, 6, 3 cross product with 1, -2, +3. Okay, I'll do a first one. So first one will be as such 18 minus -6, so it's +6, minus negative, so it's cover second one, 9 minus 3. Okay, last one will be, wait, no, I must correct. Last one will be cover minus 6. Minus 6. This will be the normal vector already. Hopefully I calculate correctly. 24, 6, negative 6, negative 12. Of course, you can just take out the 6 to make it simpler. So the plane 3 will be r dot 24, negative 6, negative 12 equal to a dot n. So of course n dot product with a position vector that's lying on plane 3, which is 3, 6, 1. 3, 6, 1. So this will give you 4 down 3, 72 minus 36 minus 12. 2 minus 36 minus 12. Okay, so it's about 24 lah. Okay, so the plane 3, I just simplify first. R dot 24 minus 6 minus 12 is equivalent to 24. So maybe on the left hand side, I divide everything by 24. Right hand side, I divide everything by 24. So this will give you R dot, okay, maybe not. I just leave it as such. No. Okay, so I will need to convert this to Cartesian. So Cartesian very simple. Just replace this thing by x, y, z. Then you will get the answer already. So it's 24x minus 6y minus 12z to give you 24. So with this, maybe I just divide the whole thing by 6. So it's divided by 6 is 4x minus y minus 2z to give you 24 divided by 6 is 4. Yeah, so that will be the so-called Cartesian equation of the plane 3. Right. So I'll say, yeah, not easier, this one.